Hello everyone. So in this pre-lecture tutorial, we're going to build on what we learned yesterday regarding solutions. Yesterday we learned about what solutions are. We learned about the parts of a solution, namely the solute and the solvent. And now we're going to start to actually get a little bit more quantitative with that material so that we're better able to understand how solutions work so that we can carry that forward and be able to analyze chemical reactions in solution. And so today's topic is going to be solubility. So let's first define what solubility is. Solubility basically just means the amount of solute that dissolves in a given amount of solvent. Okay, because as I'm sure we're aware, we cannot expect a solvent to just dissolve an infinite amount of solute. Basically, at some point you reach a limit. And so the solubility is that limit. So basically, as we consider solubility and we consider the type of mixtures that we get as we start to approach that limit of solubility, we need to define some additional terms here as well. Basically, an unsaturated solution is a solution in which more solute can dissolve in the solvent. Okay, whereas a saturated solution is a solution in which we've reached the limit of solubility for the solute in the solvent. And oftentimes I feel that actually seeing this in action is a little bit more useful than having a definition given to you. So again, I'm not sure how many of you have ever played with this in the kitchen at home, but what we have here is basically sugar being added to water. All right, so basically we're creating an aqueous solution of sugar and water. And basically what we have going on here all the way on the left is we're just starting to add the sugar, and if we go and we add and we stir, basically we still get a clear solution. Basically that means that all of the sugar that I've added has dissolved. And so at this point, basically that clear solution is still considered to be unsaturated. Okay? If I go and I proceed to add more sugar, basically as long as the sugar keeps dissolving, then basically that solution would continue to be unsaturated. But at some point, what's going to happen is I'm going to get to a point where I've added so much sugar that it stops dissolving. If you notice, basically the solute stops dissolving here. And when it stops dissolving, then basically we consider that solution to be saturated, meaning that basically it's dissolved as much solute as the solvent can handle, and that's it. Basically, if you add any more, it just stays a solid and it just sort of drops to the bottom of the container. Now, interestingly enough, it is entirely possible to actually go and exceed this limit of solubility. And if you do that, you actually get what we call a supersaturated solution. This is a solution in which the solubility limit for the solute in the solvent has been exceeded. And basically the way that you do this is you go and you actually add solute at a higher temperature. And then you carefully cool. The solution. Now, basically, these types of solutions are highly unstable. And basically, any disturbance causes the solute to solidify and just comes crashing out of solution and essentially starts to crystallize. So again, a visual is usually more helpful here. So I have a couple of pictures here to show you. So for example, this here is an example of a supersaturated solution. So notice again that the solution starts clear, but basically as they drop that probe into the solution, that disturbs the solution and all of a sudden stuff starts to crystallize out. I also thought this was an interesting picture. Basically, at the beginning of the GIF here, what you're going to see is the solution's clear, but the minute this person puts their hand in the solution, it disturbs it enough, and immediately the solute starts to crystallize out, because again, you're exceeding the solubility limit, and essentially what that does is it causes any little disturbance to cause the solute to come sort of crashing out of solution and become a solid again. So all of that is well and good, but we have to have a way of predicting what the solubility of a particular solute will be. And as it turns out, scientists like to sort of go and examine this sort of thing, experiment with it, and then document it so that other people can use this. And so that's where solubility curves come in. All right. So what you have here in this picture is an example of a solubility curve. Basically, what's going on is on the x-axis, you have solutions that have been analyzed at various temperatures, and the amount of solute that actually dissolves, in this particular case, per 100 grams of water, is measured and then plotted against temperature. So you get these traces. For example, this one's for potassium iodide. All right, this one over here is for sodium nitrate, and so on. And so we can use these to have some idea of how much of a solute I'm actually going to be able to dissolve in 100 grams of water. And so basically it's really an exercise in interpreting data and interpreting graphs. So let's actually do a few of these types of questions together. So for example, here with the solubility curve, we have the following questions. Notice that the first one is, okay, if I have potassium nitrate at 70 degrees Celsius, okay, what mass of solute will dissolve in 100 milliliters of water? Now I realize that the y-axis here says 100 grams of water, but if you remember, the density of water is 1 gram per milliliter. So as a result, 100 grams of water also happens to be 100 milliliters of water as well. And so as a result, we don't really have to worry about adjusting the y-axis scale. But essentially, if I go ahead and find potassium nitrate, or potassium nitrate is this trace right here. Okay, and if I find 70 degrees Celsius, and that's that point on the x-axis, if I go and find the intersection and then trace over to the y-axis, then basically what this tells me is I should be able to dissolve 130 grams of potassium nitrate at 70 degrees Celsius in order to achieve a saturated solution. So basically at this point, that means that I would get a saturated solution of potassium nitrate. If I'm below that point, anywhere below this point right here, this would give me an unsaturated solution of potassium nitrate at that temperature. If I'm above that value, then basically that means I am supersaturated in potassium nitrate. Let's try some of these other questions. We also have sodium chloride, and they're saying, okay, how much sodium chloride can I get in at 100 degrees Celsius in 100 milliliters of water? So once again, here's 100, right? And sodium chloride is actually this trace right here. So there's sodium chloride. Okay, and if I find 100 degrees Celsius and trace up, and then trace over to the y-axis, then basically I should get 40 grams of sodium chloride to dissolve in 100 milliliters of water there. What about ammonium chloride? Well, again, we would pretty much follow the same pattern we have been following. Ammonium chloride has this trace. Okay, and they want to know at 90 degrees, then how much ammonium chloride can I get into solution? So again, that's 90 degrees. I find the point of intersection, trace over to the y-axis, and so that means I should be able to dissolve 70 grams of ammonium chloride in 100 milliliters of water. Okay, now here's an interesting question to finish up the pre-lecture. It says, which of the above three substances is the most soluble in water at 15 degrees Celsius? So if we find 15 degrees Celsius, that's right here. Okay, and if you notice, our salts were potassium nitrate, ammonium chloride, and sodium chloride. And so they're asking at 15 degrees Celsius, which is the most soluble? And so notice that 15 degrees intersects the potassium nitrate trace there. It intersects the ammonium chloride trace here, and it intersects the sodium chloride trace essentially here. Okay, so if you go through, and it's very close between the ammonium chloride and the sodium chloride, but basically if you take a look, sodium chloride is just that tiny bit more soluble at 15 degrees Celsius than the other two salts. So go ahead and answer the questions on the pre-lecture related to solubility curves. Again, we'll go and we'll do more exercises with this particular topic in class tomorrow. Again, if you have any questions, feel free to email or to bring up your questions in class. Have a good night.